Welcome to Emerging Technology Horizons. I'm Mark Lewis, the Executive Director of NDIA's Emerging Technologies Institute. And today we're going to be talking to Ravi Ravichandran, who is the Vice President and Chief Technology Officer for the Intelligence and Security Sector of BAE Systems Incorporated. So the intelligence security sector is comprised of approximately 7,000 employees. They're spread across the United States. Annual revenues of over $1.5 billion, and they cover everything from large-scale systems engineering, integration, sustainment services. They do air, land, sea, space, and cyber domains for the U.S. Department of Defense, as well as for the intelligence community and other civilian agencies, and really support our warfighters, our troops deployed all around the world. Ravi has been in this community for a very long time, more than 25 years of experience. He's focused on technology innovation, development of prototypes. He's an expert on transitioning products to franchise programs. He's led technology and collaboration initiatives across BAE Systems. And prior to his current role, he was with the BAE Systems electronic systems area. We worked on a number of critical product and research programs. He's the author of numerous papers and patents. He's been featured in books and has published in the top journals. Received many awards internally from BAE Systems. Was selected as the Technology Solutions Entrepreneur of the Year 2012. And I remember 2012. That was kind of a fatal year. We all thought the world was ending, so we survived it. You survived it. Let's see. Ravi has his bachelor's degree in electrical engineering from Georgia Institute of Technology, the MIT of the South, and master's and doctorate degrees also in electrical engineering from Rensselaer Polytechnic Institute in Troy, New York. And he's actually still quite active with RPI. Serves on the Electrical Computer and Systems Engineering Department Advisory Board at Rensselaer Polytechnic Institute. So, Ravi, thank you so much for joining us today. And among our list of emerging technologies, obviously, artificial intelligence is one of the very top priorities for the department. I think there's universal recognition of the importance of artificial intelligence and what it can do in national defense. And at the same time, also recognition that we have peer competitors who are also investing very heavily in artificial intelligence, integrating it into their defense strategies. And so that's what I'd like us to focus on. Can you start, give us a short summary of the evolution of artificial intelligence and machine learning, and where do we stand right now? Where are we, and where do we need to be going?
Mark, thank you. First of all, thank you for the opportunity to be a part of the NDA podcast. Thank you for the very graceful introduction. Important topic, good topic. I appreciate in your introduction when we said we will want to talk about AI ML and want to go to multi-domain operations, JADC2. I'll comment on the latter. That is a war-fighting construct. I believe almost every day in one of the defense publications, we hear about that. For BAE Systems, for our industry at large, that is a North Star. It is a guiding principle, and we are working through that. So for us, it was important to think about AI ML, where we are today, and what is the path for AI ML to multi-domain operations. So what I would like to talk about in our time today, I think it helps very much to look at the history of AI ML in order to understand where we are today, and importantly, how do we get to multi-domain operations. So let me begin with the history of AI ML. One thing which is very nice about AI ML, like many technologies, there are a lot of stories about where it started. And for AML, it is, even now you can go and see a plaque. There was a summer conference at Dartmouth in 1956. I think it was 50 years later, many of the principles were still there. It was very touching. And when I think a number of magazines had a plaque, they showed pictures of before and after. So we begin in 1956, where in that they coined the term artificial intelligence. However, the field, a lot of work had been going on in that field. I'd like to have a teaser because I would like to connect that teaser to MDO. In the early ages, one of the themes for artificial intelligence was cybernetics. And one of the comments in cybernetics is how They looked at learning, they looked at estimation, they looked at control, and said, in order to get to cybernetics, you need expertise from all those fields. However, beginning in the 50s, 60s, 70s, 80s, ups and downs in terms of AI. I believe a few years ago, DARPA summarized it very well when they talked about the waves of AI. They talked about the first wave where there was a focus on rules. And one of the best things about rules is they explained things. When you saw a result, you could understand. However, the challenge for rules-based systems was scalability. They could not scale to hard problems. Then you have what we have today, a number of machine learning algorithms based on statistical algorithms. The great thing about them is that they scale very well. However, the challenge is explainability, that quite often you see an answer, and one of the criticisms is you cannot explain that. You cannot give background as to why did we get there. So now we go to the third wave. First wave was rules, explainability. Second wave was statistics, scalability. Third wave is, can you get the best of both? Can you get the best of explainability and scalability? Very hard problem, and that's where we are. I'd like to offer a couple more vignettes on how we think about AI ML today. One lens is the classical lens. And what I mean by the classical lens is when the field began in the 1950s, 60s, they talked about perception, reasoning, planning, acting, learning, communicating, abstraction, very, very foundationally hard problems. Work in all those areas continues to progress. However, in recent years, it is machine learning that has really been center stage. And it's center stage, and it became center stage in the last 20 years because you saw a confluence of three things. You saw algorithms, primarily statistical algorithms. You saw computing. And who are the leaders? NVIDIA, cloud computing, the ability to process very large amounts of data. So you had algorithms, you had computing. The other, importantly, you had data. And this was driven by Facebook, Google, people using lots of data. And that propelled primarily the commercial industry. And in the commercial industry, it is across the board where everybody has some type of data need. Agriculture, education, finance, investment, logistics, the list goes on and on and on. And they had a huge need. You saw a confluence of these three topics, these three capabilities: algorithms, algorithms, computing, and the ability to collect large amounts of data. So quite often when in today's world, when we think of AI, I believe most of the time they are referring to machine learning. In today's world, when you think of AI, you also think, especially in our engineering community, they are now sort of seeing the connection to the old cybernetics explanation of the confluence of operations research, engineering, computer science, control estimation. AI has also become a catch-all term for hard problems. So in today's world, when you think of AI, it helps to have three filters. There is the classical AI, very hard problem, very good work going on, machine learning, tremendous amount of attention, and AI as a catch-all term for hard problems.
So when I'm smiling because when I was an undergraduate, I mean, we thought of AI as can you pass the Turing test? That was AI, and most recently, so when I was in the Pentagon, we found that there was a lot of, maybe confusion isn't the right term, but conflation of AI and machine learning. And we would have these deep philosophical discussions. Is it AI? Is it machine learning? Is it both? Have we mislabeled? So thank you for pointing that out as in describing current state of the field.
When we come today, when you think of AI ML, something foundational to think about, and this is where it is the engineering foundations. All those are based on representation, how you think about the problem, and inference. Once you lay down the problem, how you compute. I'll give an example. You see this in machine learning. when you have time series data, we use recurrent neural networks because of the correlation in time. When you see images, they are spatially correlated, and that's why we have convolutional networks. Likewise, when you have states leading to actions, a state coupled with an action, we think of reinforcement learning. I give that as an example of representation and inference. And it is for, I want to comment, I'm not saying this is easy. When you think of the machine learning data problems, in a good way, you focused on the type of problem you're working on. When you think of the DoD systems problem, there is a level of complexity in terms of time, in terms of latency and time, that simply broadens the scope of this. And I believe that when we think of multi-domain operations, those are hard problems that are open to us, and that is both exciting because there's tremendous amount of work to be done, and there is it's an open challenge problem, and I'm glad to unpack that a little more next.
Yes, no, let's follow that on.
Good. Wonderful.
Yeah.
So when we think of multi-domain operations, I think many of us have seen a picture, or you can think of a picture. If you'll walk with me, you have platforms, and they're multi-domain: space, air, land, surface, subsurface. Connecting them is also cyber. You have networks, different types of comms networks. You have many types of sensors. Sensors for surveillance on a weapon, some for targeting. And then you want an outcome, you want effects. What makes multi-domain operations even more challenging is I commented on the joint nature of that. I commented on the domains, and now we come to the joint nature of that. In the United States itself, Air Force, US Navy, US Army, and now Space Force. And when we think of our peer threats, and a big theme of the 2018, the National Defense Strategy was coalitions, that we are not doing, we are going to work with our partners. So not only is the systems problem difficult from an engineering point of view, because of the joint and coalition nature, we also need to be thinking of from a policy, from a data sharing point of view. One of the themes that has come out in the JADC2 conversations is, in this network, how do we get the right data at the right time so that the right person can make the right decision? So when we think of AI and ML, it is helping build the system so that you can get the right time at the right place to the right decision maker. One of the things we talk about is, because these are connected, what we are aiming for are a handful of things. One is decision time in our favor. When you think of this as a playing field, one of the great things about this multi-domain system is we can stretch the playing field. This is where autonomous vehicles, a big theme of autonomous vehicles is, rather than having manned platforms, you can stretch the field with unmanned platforms. You can keep our warfighters out of harm's way. And one of the good things about stretching the battlefield now is also with distance comes time. You can buy time. However, when I say buy time, you want to take that advantage. How can you start closing those information loops? So this is a good segue to talk about AI, ML, and systems. What's good here is we are not inventing new things. If again, I want to go back to this community of control, estimation, and learning. This community has been thinking about this problem for a long time. And even today, when you look at a fighter, when you look at our weapon systems, they are they are closed estimation and control loops. They have I'd like to offer the best estimation algorithms and the best control algorithms. So we have a good sense of how to close that inner loop. We have a good sense of models, how to construct physical models to build those. What we are going into is a battle where there is tremendous amount of uncertainty. Uncertainty simply because the kill chains are very, very long. Uncertainty because when information goes from one to the other, information theory 101, uncertainty continues to grow. And this is where you have a control loop to shrink that. The other is we are going into a battle where there's deception. There's deception both in terms of putting noise into the system, and there's deception in terms of false targets. And this is one of the best ways to think about AI/ML in context of a system, that you have a fast inner loop with control and estimation, and you have the outer loop, which is a learning loop. Let me go back to my description of AI/ML, and this you see in AI/ML research. One of the biggest challenges is sooner or later you need a model to operate on. And a big part of current work is, where do we get models from? If you understand the physical process, models can be determined from physical processes. And in many cases, you don't have physical models. That's why we collect data and we build models from data. One can only imagine that when we have this long kill chain, the difficulty in building models to construct this. And that is why we envision this coupling of control, estimation, and learning, that you build your models, you typically would build them offline. You would, and this is where in the DoD we have tremendous work in modeling systems behavior. We have modeling components, we have modeling platforms, we have modeling large coalitions itself. So depending on where you want to go, you can model it at those levels. And this is where the DoD systems problem is very unique. I don't think we have, I want to contrast. I think this is helpful to contrast the machine learning data-oriented problem. I'm not saying it's easy. I'm simply commenting it is a different type of problem. It is still a very hard problem. The MDO problem is a systems problem. I'd like to add another complexity of a system of systems problem. And again, Mark, this is where the DoD has done a lot of good thinking. I think it was about 10 years ago, a very good DoD document on system of systems. And one of the themes there in system of systems is the biggest challenge of system of systems is independent of AI/ML or any other. You want to put together systems where they were not designed, they were designed for a purpose. And now you want to get another purpose out of them. Off the bat, that's a hard problem itself.
Sometimes the systems have been designed specifically not to work together, which I find amazing. Yeah.
Absolutely. And this is where when we comment on interoperability, data transfer, all those are hard to begin with. And now you want to build this for a very, very difficult problem.
So I love your point also about addressing speed of information. As just one example, we always point to one of the advantages of hypersonic systems is they get inside an opponent's OODA loop. Something is coming at you so quickly, even if you detect it, knowing what it is. And this is clearly an application where artificial intelligence technologies can help the warfighter. Am I right on that, or?
It is, and I think the example you gave is right on. When we commented on, we are seeing new threats, and I believe that is why we've elevated JADC2. You gave a very good use case. We need to close that kill chain at speeds faster than they're coming at us. And the observation now is, how do you close that kill chain? And that is why we comment that we want to take the best of what we have, and we want to bring AI/ML systems into that. And perhaps a next step to ask is, so how do we go about doing this? And again, this is where we are not starting from scratch. And I think like you said, I've been in this industry for a long time. I continue to champion that the DoD is a true systems engineering leader. I mean, not almost, I would say everything we build is a large system that is supposed to work together with other systems. So I'll highlight three large topics and drill down a little more on each one of them. So this is, in fact, I've always marveled that you commented on engineering education. Let me take a sidebar, and I know that in our community, this is a big topic, workforce development.
Yes, absolutely.
I'll comment on workforce development to come back to this. I find it fascinating that when we hire, we look for majors, and I'm sure engineering, computer science, math, physics, and almost everyone, we say great, 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 great. But I think it's for BA Systems, and I believe for our peers in the industry, whether large business, small business. I find it interesting that when you start working the DoD, most people end up by getting a master's degree in systems engineering because you need to understand systems. And again, I would comment that DDR&E, one of the leaders in championing that. So I give that all to say, I'll give a systems engineering view of how we break this down. So at a high level, we want to think about system engineering design. When we think of system engineering design, we want to think of three things. In this very fast loop, we know that absolutely the warfighter is the decision maker. But in your example of hypersonics, what we are doing is how can we offload their busy work to an AI system? So when we design these systems, one of the decision trades is what does the warfighter do? What does the AI system do? I would like to comment again on DoD systems. What we are talking about here are decisions with high consequence actions, very, very sober decision making. And that's why I want to give a shout out to the community that is thinking of AI and ethics, a big topic, because what we are talking about is high consequence of decisions.
Right. If Facebook misidentifies your Uncle Henry, you laugh about it. No harm, no foul. If a defense AI system misidentifies a target, that could be a really bad day for lots of people. So I agree with you. The consequences are very different.
Absolutely. And I think let me get to the test evaluation V&V that's late in my comments here. So absolutely yes. So system engineering design, one decision is warfighter AI system. When we think of the AI system, we commented on the integration of control, estimation, and learning. And what's we are in a very, I would say I would love to go back and do another PhD because a very exciting time to be in that field.
By the way, I could not do another
interesting.
PhD, just for the record.
So in full disclosure, I don't think I'd even get into any of the schools I went to
yeah.
because the competition is so fabulous. I only marvel at how interesting the topics are. And if you go back in the 70s, 80s, I remember even at MIT, the LIDS department was a front runner in the looking at estimation and control. And now how exciting it is to look at estimation, control, and learning. So when we think of algorithms, where does it sit? And then I briefly commented on AI for AI algorithms itself. Not that it's a debate, it's simply where we're getting information from. Model-based, data-based. For model-based, how do we go to fundamental understandings of physical systems, how systems come together, and models, and then data-based. Where do we get data? And Mark, if you've seen the literature in the last year, especially I've seen a lot of literature in the last 6 months. For database, you need labeled data, and the comment on how hard it is to get labeled data as well. Hard problems. Anyway, this is a description of system engineering design. Once you have system engineering design, you've identified different components. Now we want to look at component design. And likewise, when you look at a component, we want to understand what part of that component is going to be built on AI systems. With all due respect to our friends at Facebook, I want to go to the next topic in design is we design systems for adversarial environments where the adversary, there's comms breakdown, there is weather breakdown. So even the best of circumstances, things are breaking down. On top of that, you have an adversary who is intentionally deceiving you. He's either putting noise into the system or he's putting false targets in the system. Very difficult problem. So we are at the adversarial environment, and the other, we want to design these systems to get warfighters out of harm's way. So we think of these systems operating at the edge. So we are limited computation. And at the edge, by default, well, when I say default, I want to be careful when I say that. Comms is a huge challenge. So when you define these components, we need to be thinking about that. So we have the system in design. We design the components. Now we need to integrate them. We need to be thinking about integrated system design. A big theme there is the earlier comment you commented on, Mark. Test evaluation, validation, verification. In our community, big topic. I'll be careful how I say this. On our large programs, they're hard. We put budget for TVNV, and usually the budget that gets shrunken at the end of the program is the TVNV budget.
I've experienced that myself.
So, want to point that out, how important that is. And again, this is where we are in a great community. Over the last many years, I've seen great teams from Army Research Office, from ARL, from ONR on thinking about TEV&V, of putting bounds. And this is where we go to systems engineering thinking to say, we want performance bounds. These are hard problems, but we need to be thinking that. And the final comment, when you talk about integrated systems, and this is the beauty of AI-based systems, they are software focused. And the idea is that you can have a system in the field, and perhaps Tesla is a good example of this, where they have a car, and when they do a software update,
Right.
they send the update down. And I think that is something we can learn from. So we think of our kill chain, we think of these systems of systems, and we can learn from our peers in the commercial industry. What does it mean to have updates in the field? But these updates have to be, we have tough performance bounds, tough performance constraints. So when I think of MDO, when I think of AI ML, these are how I think about the problem of how our peers are thinking about this and how we are thinking about engaging with the community.
Absolutely. Ravi, our time is winding down, but I could talk to you about this all day as absolutely fascinating discussion. Any closing thoughts, challenges, opportunities that you think the department needs to focus upon?
So I hope imitation is a form of flattery. I would encourage, it's a big report. Our community, there's no shortage of good reports. And like anything hard, you have to read them, you have to think about them. I think the NSC AI final report that came out early in the year, very large document, 700 plus pages. I like reading things. I've read most of it. It is spot on. And so to me, one of the best things it did, it is elevated the challenge in our community. I heard Dr. Work give a presentation on that, where he commented again on we are facing a peer threat, how important this problem is. And it's a big report, but if you go through the report for our community, there are a handful of pages where there are excellent summaries. They had a summary of research challenges. They had a very nice problem focused on the IC community, and they had a very nice problem description based on their DoD community for a C2ISR problem. So final thoughts are, let's keep working together. We have very good people. Frankly, a very exciting time to be engaged in this community, because thoughts where as a group, we've been thinking about these problems for a long time. we are at a place now. We have lots of good people thinking about it. We have lots of tools. The department does a great job in doing tests and exercises and collecting data. And let's go full
Dr.
speed
Ravi
ahead.
Ravichandran, thank you so much for joining me today. Again, been a fascinating conversation. Thanks for all that you do, by the way. You know, as one of our industry leaders, your contributions are so appreciated. And I hope we can do a follow-on conversation because I feel like we've just begun to
Absolutely.
probe the outer envelope of what artificial intelligence can do for the department.
It is, and especially I wave a big flag of artificial intelligence for systems. We don't have enough smart people thinking about that problem. In a good way, we have artificial intelligence are very focused on what I call the ML data problems. Very hard problem. We need lots of people there as well. I want to wave a flag to say for MDO is fundamentally a systems problem, fundamentally a systems of systems problem. Opens up a whole array of challenges we need
We'll
to be
make that the
thinking
last
about.
word. Thank you again for joining me.
Thank you. Thank you very much.